In CoCalc, it's now possible to uh, use on-prem resources connected to a CoCalc project. Basically, if you have a CoCalc project on which you're using collaborative Jupyter notebooks, terminals, editing files, etc., and you need more compute resources and you just happen to have them. For example, you have a powerful laptop with lots of memory, or you can run a VM somewhere in the cloud. You can then connect that to CoCalc and run your notebooks and terminals and so on those resources. So let me illustrate that as follows. So first, we're in CoCalc right now. I've signed in. I'm going to click here to open my list of projects. And then I have a project called Demo. And in this project, let's create a Jupyter notebook, which I'll also call Demo Jupyter Notebook. And I'll just use the Python 3 kernel, and I'll do something let's see, I'll use GenAI to do something. So compute the prime numbers up to 1,000. And I can choose from any of this wide range of models that we support. Maybe let's use Claude 3 Opus 8K. Okay, so this will use this new Claude model. It's computing a list of primes, and then it's going to print it out. So let's run the actual code, and there it is, and that looks good. Make sure it's 168. It is, excellent. Okay, so now that we have this, let's move it to a compute server where the compute server runs on my laptop. Okay, so first I'm going to click New Compute Server. And instead of running on Google Cloud, I'm going to run it on-prem, which gives me the ability to really run it anywhere. So I'll call it Demo Server. And I'll choose a different color. How about this orange? My laptop, which is where I'm going to run, or first show you how to run a compute server, has an ARM processor. It's a MacBook with the new M1 processor. Okay, and I'll use the Python image. There's lots of other images you can choose from, for example, Sage, Anaconda, Julia, but for our purposes, let's choose Python. Since the kernel I was just using is a Python kernel. Okay, we can leave everything else exactly as is, and now let's create our compute server. So here it is. It's just a thing here, and what we need to do is click Start, and then we have to actually do some work to create the compute server. So I'll first click Start. And notice it says you have to use an Ubuntu 2204 virtual machine. So that's what we need. Somewhere we need an Ubuntu virtual machine. So on my Mac, I'll click Terminal. And note the suggestion, multipass is an easy way to get a free Ubuntu VM. So multipass is a program that's very easy to install. And I've already installed it. You go to the website multipass.run, you click Install Now. It'll give you an installer for Windows, Mac, or Linux. You then install it. And once you've installed it, you'll have the ability to run the multipass command in a terminal. So notice I can do multipass-h, and I see that I have this program called multipass available. Okay, so now the instructions here say that I need to create a virtual machine, and I'll just go with the defaults. And when I type this, it then creates the CoCalc virtual machine running on my laptop. So it's downloading the latest version of Ubuntu. It's going to then create the virtual machine. And once it's created, I will get a shell on the virtual machine, as illustrated here. And then finally, I will copy and paste this single line of code into that shell. And what will happen is various software will get installed into that Ubuntu VM that's running on my laptop, including Docker. Actually, Docker is the main thing it installs. Once it's installed Docker, it will then run, it also installs Node.js, and it will pull in a couple of Docker images that are needed to run a very lightweight, small version of CoCalc in that virtual machine. Once that thing starts running, it will then connect to CoCalc.com via a WebSocket connection, and that will give it access to the files in this project, and also it will be able to provide its compute power for the purposes of running Jupyter notebooks and terminals. Okay, so our virtual machine is now running. If I do multipass, I think it's list, it shows it's running. And now I'll do multipass, well, I can just copy paste it from over here. Multipass shell CoCalc. Boom. I now have a shell inside my virtual machine that's running on my Mac laptop. Finally, I'm going to copy and paste this line of code into that shell. If you're going to run one of these, by the way, for a very long time, you might want to use tmux or something so you can run this line of code in the background and come back to it later. But in any case, I just pasted it in, and now it's starting up my compute server. So on the right, you'll see that it downloads and installs various things. Right now it's installing Docker. And as the installation proceeds, this blue bar is going to move. And it's not like a fake progress bar. As the installation runs, it's telling CoCalc how far it's got along the way in terms of doing the installation. And when it gets to the end, it will then start a couple of Docker containers, two of them, one for the file system and the other for our Python terminal and Jupyter notebook server situation. Okay, it started up the file system. That's all mounted and ready to go. The Python image is now downloading, and notice it's a couple of 100 megabytes. If you chose the Sage image, it would be much bigger. So be careful which image you choose. If you want to see the sizes of the images, click the little advanced checkbox next to the image option. And you can make multiple on-prem compute servers on the same physical machine just by creating different virtual machines, for example, using multipass. Okay, so it looks like everything is done and up and running. We're just waiting for this little Python container to finish its startup process, which should finish in a moment. And there it is. Now it's completely done. And now switching back to CoCalc, we now have this on-prem compute server. The upshot of that is if we go to our Jupyter notebook and then we click on server, remember this is where we clicked to make a new compute server. We now have the server and we can move our notebook so that it's running on the compute server. So I just click there, run the notebook on the server. It's now connecting and here we are. So now I can run this code again, but instead of it running on CoCalc, you can see it starting up, it just ran on the compute server. So this is now running on my laptop. And how do you know that? So we can run some commands. So maybe hostname, that's a good one. So it's running on compute server 3262. And another thing you could do is free-g to see the memory. So there's 7 gigabytes of memory. The amount of memory is determined by what I did on the compute server. And let's see, we could draw a plot. So import pylab.plot let's plot the primes. That's gonna look funny, but there it is. So there's a plot of primes up to 1,000, whatever that means. So here we are. You can also get a terminal directly on this compute server. You can do that in a couple of different ways. One is here in the application menu, you can say I'd like a new frame that's a terminal. If you do that, you'll get a new terminal, and it's offering to run it either in the project, our default shared resources, or on our compute server. So let's run it on the compute server. And here it is. It's now running on the compute server. So this is on that compute server. Okay, so we have a compute server, it's up and running, and we can, maybe launch difficult computations on here. Other people can add them as collaborators, and then they can also open this notebook or create their own notebooks or other applications and run them on this compute server. Okay. Next, I'm going to delete this compute server, and then I'm going to create another one, but instead of it running on my laptop, I'm going to have it run on a third-party GPU cloud provider. Okay, so first, how do we shut down this compute server? So I'll go to settings and then deprovision, because I don't necessarily care about any of the data on this compute server. So I'll say yes, deprovision. It gives me a line of code to paste in. So I'll hit Control-C to stop that script running. I'll paste this line of code in, and boom, the compute server stops, gets cleaned up, and deprovisioned. And it's stopping the file system, unmounting everything, stopping Jupyter running, etc., etc., etc. Okay, we'll let that go. We don't need to wait for that. Just leave it. And now let's make a brand new compute server. In addition to using this dropdown, you can also click on the servers tab and then create compute server. So here I'm going to try to create, again, an on-prem compute server on Lambda Cloud, which is a GPU cloud provider, which has very spotty availability. So let's hope there's a GPU available right now. Let's give it a nice red color. These are x86 machines, and they have an NVIDIA GPU. So we will choose an option with an NVIDIA GPU. So we'll use this Python Anaconda option. Okay. And otherwise, there we are. Don't need to change anything else. So let's create the server. And as the demo server is done being deprovisioned, and at this point we could just delete it. Okay, so now I want to start this on Lambda Cloud. So I'm not going to use multipass because Lambda Cloud already gives you an Ubuntu 2204 virtual machine. So let's open a new tab, go to Lambda Labs, click on Launch GPU Instance, sign in, launch instance, and what do we have? So there's an A10 available, and there's also a fancy schmancy H100 available, maybe. So let's give it a shot. Looks like there's exactly one region where it's available. We don't need to attach a file system, and we definitely need an SSH key, otherwise we won't be able to SSH in and paste that line of code in. So I'm going to use my SSH key from my laptop. So that's my public key. There it is. I'll call it my laptop. Add SSH key. I agree to whatever. Definitely not going to mine cryptocurrency. And our instance is now booting. So what will happen is in the next couple of minutes, this H100 is going to boot up. Unless I ran out of credit. Let me check to make sure I have money on my account. How do I do that? I have no idea. Oh, they bill you later, I think, so I don't need to add money ahead of time. So we just have to wait for this to boot, and there's really no telling how long it will be. By the way, you could do this process with pretty much any cloud provider. You could try CoreWeave or anything else. But there's a bit of copy and pasting, but hopefully it's useful. So once it's ready, we're going to SSH in and copy this one line. So again, I don't know how long this will take. I'm just going to refresh and wait. We have an IP address. That's a good sign. I can get impatient and try to SSH into it. It shouldn't work yet, probably, because it still says booting, but it's worth a try. Meantime, I'm going to go over to this multipass thing on my laptop and delete the machine I made. Oops. Pass list, multipass delete CoCalc. Okay. All right, still waiting for this H100 to actually exist. All right, we have no instances. Okay, so we're just waiting for this Lambda Cloud instance to appear. Waiting. No idea how long it will take. Fortunately for you, in the real world, I will edit this out. Call this demo. Connection refused. That's a good sign. It's not just hanging. That means there's something sitting there. And boom, we're in. Okay, so now all we have to do, go over here, copy and paste this line. Boom. And there it goes. Okay, so our compute server is once again starting up, just like before, except now it's running on Lambda Cloud. And it's going through the same process as it did on my laptop. Maybe it's a little faster because this is a very, very beefy machine. Has super fast internet, lots of processors, lots of memory, and it's doing the same thing. It's downloading the code for the file system mount, and then it will download the code for the Anaconda Python image, and then we'll be able to test it out. So there it goes. One thing with, you can also create compute servers on Google Cloud where you don't have to copy or paste anything. That's just another one of the options next to On-Prem. They have these like Docker images and so on pre-pulled, so that speeds up the startup process quite a bit. Also, this process is, you do it once and then you don't have to do it again once you've created the virtual machine. Okay, look, it's almost done. So now we're just waiting for Python to, the Anaconda image to get extracted. Then that Docker container will start up, connect to CoCalc, and then boom, we'll be able to run notebooks and so on. And this has an H100, so we can try out something like PyTorch or TensorFlow, and it has acceleration from an extremely powerful GPU. So let's wait and see that work. And it's very easy to use Anaconda to install things like PyTorch and TensorFlow, or Sage, or really anything else you need from the scientific Python ecosystem. All right, looks like we're almost there. Just a little bit longer. Almost there. And it is extracted. Oh, there's another one. And once this extracts, it starts the Python Docker container running, and then connects to CoCalc, as I just mentioned. So come on, downloaded, and here it is. Okay, so it's now running the container. That takes a second because it has to make sure the file system's been properly mounted and connect to CoCalc. And in a moment that will finish, and then this will be at 100%, and we'll be able to use it. Yes. Okay, so now let's give it a shot. So go to the Explorer. We can either open the notebook and then try it and then set it to run on Lambda Cloud, or we can make a terminal, and I'll do that for fun. So I'll click New, and I'd like to have a Linux terminal. and I'm going to run it on Lambda Cloud. I'm setting the terminal to run on the compute server. And I want to poke around a little bit to just make sure things look right. So first, if I type top, I should see lots of processors, lots of memory. Most importantly, if I type NVIDIA SMI, I should see that we have an H100 with 80 gigabytes of memory. And there it is, our NVIDIA H100. I'm going to type conda install PyTorch so that that gets installed because it's not installed by default. So let's give that, or let's let that run. That will take about a minute. In the meantime, I'm going to switch over and make this notebook run on our new compute server. So close that, and I'll make it run on Lambda Cloud. Okay, boom, it's now running on there. We can rerun the primes thing, but something we can't do is use PyTorch. So yeah, the primes thing just ran, but let's try import torch. And that should give an error because torch is not installed yet. And it's currently being downloaded. So it's using conda and it's installing PyTorch. You can also do pip install PyTorch. You get something kind of different. When you do conda install PyTorch, it's, I think, more dependencies are installed. It's a bit bigger, but it properly installs PyTorch into the conda environment. And if you do pip install, it just grabs whatever the latest version is from PyPy. So it's probably safer to do conda install PyTorch. So let's let this finish, which should take about a minute, at which point we'll have PyTorch installed and we can then use it. And actually over in our notebook, while we're waiting for this little thing to finish off, let's use generative AI to generate something interesting using PyTorch. So show me let's see, we used Claude 3 before. Just for fun, let's try Mistral Large. Create a cool example using PyTorch that illustrates using a GPU to train a very, very basic model. Okay. That is not good. So apparently something went wrong with Mistral. So I'll try again, but using a different AI model. All right, I'll try Claude Opus again. Create a simple example illustrating use of PyTorch with a GPU to train a basic model. This should be self-contained and run and work. Okay, so let's give that a go. Okay, so it's creating a model, it's making sure it runs on the GPU, and then it's training the model and printing out information as it trains it. And I noticed it didn't write import torch because I think it knows we already tried that up, or it just assumed it, so I'll put import torch. Also, in the meantime, let's check in the terminal, make sure that we have PyTorch installed. We do. I'll just do a quick check here for fun, import torch. And yes, that is available. Torch.cuda is available. Let's make sure it knows about our GPU. Yes. All right, let's try running this model that popped out, or running this example, and there it is. It noticed that there's a CUDA device, and then it ran the training. So excellent. So that illustrates using on-prem. And the situation, by the way, when we're done, is just the same. So we can look at all of our compute servers here, and then we can deprovision this one. You can also always just click on this bar at the top. Oh, it's a good idea, by the way, to click sync. Then any data that's stored on the compute server gets synchronized back to your project, so you can see it here and work with it further, except data that's in the special local fast directory. There's a directory that you can see on the compute server here called compute server 3264, that's the ID of the compute server. Data that's there doesn't get synchronized back and forth, and it's a great place to store lots and lots of data that you want very fast access to, but you don't need to keep it long term. Okay, so let's deprovision this compute server. So I click deprovision, yep, and then I'm going to just copy that line, put it into the terminal here on Lambda Cloud, and it will shut it down. And then it will be deprovisioned. And then I also have to remember to explicitly turn off the virtual machine that I'm running on Lambda Cloud, because they're charging me a lot of money while I'm running it. So as soon as this is done, I'm going to just shut that virtual machine down. Okay, it's done, deprovisioned. Go back over to Lambda Cloud, click on the checkbox, and how do I terminate? Yes, terminate. All data will be erased, that's fine. Or I have to click that. Now terminate instances. Okay, will no longer be charged, and it's now terminating. Excellent, so thus concludes my demo of using on-prem compute servers on CoCalc. Thank you.